Okay, so the horizontal line test. This test, if you know what the graph of your function looks like, saves us from having to go through the last two examples. So I know that sometimes showing something is or is not one-to-one is kind of a tedious process, right? It's a lot more theoretical than I think what we're used to in this class. So if you can identify the graph of that function, you can use the horizontal line test as a much quicker way of determining whether or not something is one-to-one. And hopefully you remember the vertical line test. We used the vertical line test back in chapter 1 at the very beginning of this class. And what that did is if a vertical line, and let me grab a vertical line here, if a vertical line crossed a function more than once, or crossed a graph more than once, it was no longer a function, right? And this works in the exact same way. So you can tell with both of these that these are in fact functions, right? Vertical lines that I draw anywhere at all on this graph will only cross one time, as well as this one over here. Any vertical line, we're assuming I draw straight lines, but any vertical line I draw, it only crosses once, right? So both of these are functions. However, are they both also one-to-one functions? And what do their inverses potentially look like? And that's some of the things we'll get into as we move forward. So this function here, this first one for part A, you can see there are two horizontal lines that are already drawn in, right? We have a horizontal line here, and we have another one below it. What's the problem with this? Each of these horizontal lines cross our graph more than once, right? And again, this is any horizontal line we draw, because if we drew one at the bottom, I could say, well, it only crosses once, right, at the vertex. But that's me being really selective, and this has to work for all points on my graph. So this does not pass our HLT, our horizontal line test. So this is not one-to-one. It's still a function. I can't take that away, but this is not one-to-one. How about our second one over here? So again, you see some horizontal lines that are drawn in. So you have one up here, there's another one down here, and another one down here. And we could draw plenty more, right? There's nothing special about these lines. But no matter where we draw these in, how many times are we only going to cross? We're only going to cross a single time, right? There's only these individual single points. So this is only going to cross once. This does pass, so as opposed to does not, does pass the horizontal line test, which means it is one-to-one. So is one-to-one. This also means that its inverse is a function, right? Over here, its inverse is not a function, which means it's only a relation. So if we were to just do a quick sketch, and I don't want these to take up too much more time, but for part A, if we were to do a quick sketch of the inverse of this, it would look like a sideways, a horizontal parabola, right? We saw those back a chapter or so ago. Now, if we draw a vertical line through these, let me go back to my green here. If we draw a vertical line through these, do you see that this does not pass the vertical line test? That is completely related to this statement right here. If it's not one-to-one, its inverse is not going to be a function. The top one up here, if we were to look at its inverse, it would look something like this. Do you see that this still passes the vertical line test? Right? So this is not a function, and this is the inverse. And this is also the inverse, and this is a function. And that's really what we're trying to get at here. What happens when we take the inverse? Is it going to be a function? Are there going to be other characteristics it'll have or not? Okay? I'll see you in the examples on the next page.